Hi everyone, today I'm going to talk about developing a data pipeline on cloud for data analytics and ML project. My name is Kamolphan Liwprasert. I'm a machine learning engineer at Certis. I have a background in data engineer and I love to build stuff on cloud. For every ML projects or data analytic projects, the need of a good data pipeline is the solid foundation. But the data is not always ready to use at the beginning. Either it is not always clean or we don't have the pipeline to manage the data. Moreover, we need to think about the automation and scalability as the project is go on. So that is the need of developing a data pipeline. So today I'm going to talk about why do we need a data pipeline, what are our options on cloud, whether it is the storage, compute or pipelines, and I'm going to introduce Apache Airflow and going to have some different architecture and demo code. Let's get started. So why do we need the data pipeline? As I have mentioned before, the purpose of the data pipeline are first to ingest the data from multiple sources because the data can be from either database, from the REST API, and we need to gather all those kind of data in together in our project. Next is we need to transform or clean the data to ensure the best quality of the data. With the best quality of data, we have the great quality of model. And the last one is about the automation of the process. Everyone will hate the manual work. It is very tedious. And if we have leveraged the automation, it would our life easier. So what are options on cloud? This one is a diagram of the data storage decision tree. Let's focus on this part about data analytics workload. In this part, if we are going to have the low latency use case, I would recommend for Google Cloud Bigtable because it is the NoSQL database which have very low latency. But if we are going to have the data warehouse, I would suggest the BigQuery, which is the serverless enterprise data warehouse, and it have the SQL interface, and it make it easier to interact with it. And also another one is Google Cloud Storage. I suggest it for the object storage and data lake. Next part is about choosing the compute option. We have Google Cloud provide a wide range of compute option, starting from the Google Compute Engine as a VM, where you can lift and shift your application directly. If you need the Kubernetes cluster, I would recommend for the Google Kubernetes Engine, which is the managed service for Kubernetes. It is very easy to create. But if you're going for serverless for the container, I would suggest Cloud Run to make your container run in scale. The next thing is about the platform. For the Google App Engine, it provides a platform that you can deploy the web application. Whether it is the Java, Python, or Go, you can deploy the whole application on this platform, and it provides you the ability to do the load balancing and traffic channeling. And the last one is about Google Cloud Function, where you can develop your function and deploy it on cloud, and then you can get the HTTP endpoint instantly. So these are the basic options that you can get from Google Cloud. If you are going to use the data processing option, in data processing, we need to think about where do data process and about the workflow and scheduler to make it automation. For the workflow and scheduler, there are cloud scheduler, which is a serverless scheduler where you can just put your scheduler in the cron format and you can trigger into HTTP or PubSub topic. Next thing is a new service. It is the cloud workflow, which is you can define your workflow and let it run step by step. For processing data, we have the option one, which is the serverless option. We have the Google Cloud Function and Cloud Run that you can create the endpoint to process data on demand. And these two are scale well as well. We are looking into the detail in the later slide. The second option is for process the big data. We have the Cloud Data Park and Cloud Data Flow here. And the third option is about the Google Cloud Composer. The Cloud Composer is the managed Airflow service that it can cover on both data processing part and workflow and scheduler part. Let's see in detail. On the option 1, which is the low cost and serverless option, we will need the scheduler as a Google Cloud Scheduler, and it will trigger based on each time of the day to the Cloud function and Cloud Run. This tool is recommended for the light workload because they are limited in resource, but they can scale very well. The good thing about this option is, first, it's serverless, so it is easy to develop and very fast to deploy. Next is it low cost. You can just start from the free tier because Google Cloud has provided quite generous free tier and you can start from $0 and pay as you go. And lastly, it's suitable for the light workload because of the limitation of the compute spec of these two services. For the next option, if you have the big data workload, I would recommend the Google Cloud Dataproc and Google Cloud Dataflow. Dataproc is good for Spark and Hadoop workload, where you can create a cluster to process the big data job. It also supports a wide range of Hadoop framework. And next is the Google Cloud Dataflow. It is a unified data pipeline where you can using the same pipeline for both batch and streaming workload using the Apache Beam API. Apache Beam is also an open source project that is support for multiple runners as well. The benefit of big data solution are, first, it supports the big data framework such as Spark, Beam, and Flink. Next is it supports well with the scalability and reliability because this workload is designed for the big data solution. And lastly, they are open source. It means it's not locked into the Google Cloud. You can run your job anywhere. And the third option is Google Cloud Composer, which is the managed service of Apache Airflow. Behind the scene, Google Cloud Composer using Kubernetes engine and Cloud SQL to make it scalable and reliable. The benefit of option 3 is it's easier to maintenance. You can ensure that Apache Airflow it is installed with the best practice, and you don't need to manage anything with that since it is the managed service. Next is scalability and reliability by the power of Kubernetes. And lastly, it's suitable for the large number of jobs that require a lot of workers. Apache Airflow is also suitable for manage the large number of jobs, which I can show you the UI in the next slide. And with Apache Airflow, it also supports all the previous options that we have discussed before. By using the specific operator or just call the REST API, you can also using it together with the rest of the service. So it can connect to a wide range of services. Let me introducing you to Apache Airflow. Airflow is a popular open source project that it is made for ETL and data pipeline orchestration. It is maintained by Apache Software Foundation, and all codes are in Python, which is easy to learn and easy to use. It can also run anywhere. Even it is locally, you can run in the Docker, you can run in the Kubernetes, or even the Cloud Composer. That's why a lot of people also interested in Apache Airflow. It has got 22,000 stars on GitHub as of today. Airflow is rich in third-party integration. It uses the word called providers, which means the package to connect into other services. Not only Google Cloud, but also Amazon AWS, Microsoft Azure, and many more. You can check all this also in the GitHub, in the folder of providers, and you can see all the integration that Airflow can integrate to. And the next thing that I like about Apache Airflow is the user interface. This is the screen of user interface, which is called DAX, stand for Directed Acyclic Graph, where you can see all the pipeline in here. You can enable and disable it easily on this toggle, and you can see about the past execution run. On the dark green here, it is the success job, the light green is running job, and the red one is error, etc. The next screen is about the calendar view, where you can see the execution run in terms of calendar, similar to in GitHub profile. And lastly is about the tree view, where you can see each of your tasks in detail, how these tasks run in the past, if it's successfully run or if it failed, you can see from this diagram. Next is let's introducing you to the basic component of Apache Airflow. There are some keywords that it has been used in Apache Airflow, such as sensor, which is then component to waiting for an event. If, for example, it will poking for a file if the file is ready or not. If it's ready, it will continue to the next one. It's called operator. The operator is the one who is running an action. For example, Python operator or BigQuery operator. And the last one is the hook. Hooks mean interface to an internal service or system. This one is not directly used, but it has been used inside the sensor and operator. So this one is the thing behind the scene. But it is very good to know that. The last part is reference architecture and demo code. Since we have the limited of time today, I will go through the code demo quickly. So today I'm going to talk about the batch ingestion. For the batch ingestion, it is the pipeline to integrate data from one sources to the another. Finally, let's see the code. You can find all the code that used in this demo inside this link. First, we need to import all the packages and all components that we are going to use at the beginning. Then we will initialize the DAG, which is stand for Directed Acyclic Graph. We will have the DAG's name. In this case, it's called ingest to BigQuery. And you can set the schedule here in the cron format. After that, we will use the SFTP sensor to waiting for our file. In here, we need to create the SFTP connection in the connection UI in the Apache Airflow webpage. And then you can specify the path to file. Let's assume that we start from an SFTP server. We have a server and then we implement a sensor to looking for a file. When it's going into the Google Cloud Composer, the file is coming and it will upload that file to the Google Cloud storage using SFTP to GCS operator. And next, after the data is in the Google Cloud storage, it will import the data into the BigQuery using the GCS to BigQuery operator. And from BigQuery, you can use an analytic workload or further transform your data, and you can show it on BI dashboard as well. To summarize, our DAG is contain 3 tasks. The first one starting from sensor to check whether the file is ready or not. Then it will upload to GCS, and lastly, it will load that file to BigQuery. You can use the function here in order to determine the file path. Next is SFTP to GCS operator, where it will upload the files from SFTP to GCS. In this here, we will need to create one more TCP connection into the same connection UI, and also identify one more path for the destination path on GCS together with the bucket name. And the last one is GCS to BigQuery operator, where in this one you have a lot of options to customize. The source object is mean the source path file of the GCS, where you can import multiple files in the list. You can specify the source format of the data, whether it is a CSV or Parquet or Airflow, as the BigQuery support. You can specify more options about how to create a table, how to append the table or replace the table. And for the schema field of the table, it will read the dictionary of the schema, or you can import from the JSON schema file as well. And lastly, we will need to identify the dataset table, where you will need to identify your table ID as a destination table with the dataset.table name that you're going to upload. And when it loads into the Apache Airflow, It will show on the UI like this. Notice the notation on the left-hand side. It will show that the brown operator is mean GCS to be query operator. The blue one is the SFTP sensor and the white one is SFTP to GCS operator. And that is our first pipeline on the Apache Airflow. Key to take away is choosing the right solution for the data pipeline. It depends on the requirement and each type of workload, whether we need the serverless or we have the large number of jobs that we would like to go for the Apache Airflow. It's totally up to you who decide whether what to use. Thank you for the listening. Let's connect with the LinkedIn and my GitHub. And thank you, Women Developer Academy, that helped shaping up this presentation. Have a good day.